Alright, let's get into the next topic, the classes and their relationships. We have talked about how to design a system using object-oriented technologies at the very beginning of the chapter. Now we have a tool, the name is UML. We're using this tool to describe class and the relationships in diagrams. So just like drawing, we join a picture. This picture is about class and their relationships. Once we get to diagrams, the next step is very easy to do. Yes, it's using Java to write the code to present the classes and the relationships. So we got the code. So the step is we're designing our system using UML. And then the next step, the coding. Okay. So what is the UML? The UML stands for the Unified Modeling Language. So it's a language, but it's not a program language. It's a descriptive language, which is used to provide us a standard way to design the system and in graphics. So it's a very interesting language, just like drawing a picture. Instead, you're drawing your system. So UML gives us a way to visualize the system architecture, to write down the blueprint in diagrams, to draw a picture about our system. Well, we have two kinds of UML diagrams. The first is static, or we limit structure or view. The next is dynamic, or we limit behavior view. The two kinds of different view. The static view, well, we describe the static structure of the system. Yeah. Just as we have a camera, we take photos, and static photos, we get the information of the system. So we use the static view of this system. Inside of system, there's objects and the relationships. The next is dynamic view. Dynamic view, like a recorder, a video recorder. We use a video recorder and we, well, get the whole information about the system. And the system is doing everything with the time. As the time passed, what happened? As time passed, how the objects, well, they connect with each other, how they communicate with each other, and work as a team to finish the task. It's a dynamic view. So I will give example about these two kinds of diagram. The first example is a class diagram. It's a static view. It describes a class. The class, as we know, it's a blueprint or a prototype of an object. So have a class. The name is bank count. So we use a block. Here's a block, and inside the block, we divide the block to three small blocks. The first block is a name of a class. The second block is we put all these variables. of the class into this block. And the third block is the method. We put all these methods into this block. So a class diagram is composed of 3 small blocks. Here we have a bank account. A bank account, a variable, 2 variables here. One is owner, like you or me. We have the bank account. We have account in this bank. So it's my name. So notice here we describe this variables. The format is the left side is the name of the variable, and then with a colon here, and the right side is a type of this variable. For example, the owner's name is a string, so we use string as a type of this variable. The next variable is balance. The balance is a count, so it must have a type of currency or type of money. For example, dollars. Okay. This is about these variables inside this class. This block is, we put all these methods into this block, and it's methods. We have 2 methods here to operating on this count, 2 kinds of operations. Deposit money or withdraw money. So we have deposit, this is method, and the withdraw method. Deposit money, here's a parameter, is the money we put into account. And withdraw money, with these parameters, we get money from the bank. This is how this class diagram is very easy. 3 small blocks. Class name, variable, and methods. Next, we see some dynamic diagrams. The sequence diagram means where we have 3 objects. For example, the customers, the ATM machine, and the server. There's 3 objects, and the sequence diagram will describe the activity, the connect, or the communicate among these objects to finish a task. For example, we go to the ATM machine, we want to get some money from the machine. So the first step, we get a bank card, we insert bank card into an ATM machine into a card reader. So the first step is insert card. And then the ATM object will require to input your password. So the next step, input password. And then the next step, the ATM objects get your password, and it will send your password to remote server to check your password is correct or not, to validate your password, and the server will get the result. Well, it's okay, or it's error. If it passed, the password is correct, then the next step, the ATM machine will receive your operation. For example, you want to withdraw some money, so input your lump of money you want to get from this machine. For example, $10. And then the ATM machine will send this number of money to the server. And the server, because you have account in the bank, it will check your balance to check out if there's enough money on your balance. If it is, it will return, okay, you can get a lump of money from this machine. So the ATM machine will give money to you. This is just a whole process with store money from this ATM machine. So this is sequence diagram. It describes the whole tasks, how the 3 objects, customers, ATM, and the servers, how to communicate with each other and finish this task. It's about sequence diagram. It's one of these dynamic view of the UML. So this is about the UML diagrams. And in the future, inside our course, I will give more examples about this UML application. And if you want to get more information about UML, about this interesting descriptive language, and you can check out this address and get more information about the UML languages. Or you can get some useful books or articles online. Next, I will give some examples about how to use these UML languages to describe a class and their relationships, as we talked about before. The first, how to describe a class using UML. For example, the bicycle. Now we have a bicycle object. Inside the bicycle object, as we know, there are three different variables: the speed, the RPM, the rotation of this pedal, and this gears. And we have three operations, three methods: change gears, and brake, and change cadence. This is about this object. So how to describe it? Use the class diagram. We have a block, and the block, we divide the block into three small blocks. Remember, the first small block, we put the name of class, bicycle. Be sure, make the first letter the big B. It is a default name policy for a class name. The second small blocks, we put all these variables inside this block. We have three variables: the speed of the bicycle, the gear, and the cadence. And they are all this same type, integer. We're talking about this kind of variable type in the future. In the next chapter, we're talking about this language features, how to define the different kinds of variable type. So int is one of these types, and the gear and the cadence. And the left side, we have a minus symbol. This symbol means the scope of these variables. The scope is private. What does it mean? We will give you more information in the future class. I think it's in the 1, 2, 3, 4. Yeah, in the 5th chapter, we'll give you more information about the scope. This is about all these variables, the three different variables here. And the next blocks, we put these methods inside. The three methods for the three different variables. The three methods is brake, and change gears, and change cadence. And the same, here we have a colon, and the left side of the colon is the name of method, and the right side of colon is the return type of this method. That's return type. And brake or change gears or change cadence, they don't need to return anything. So we use void, use this keyword here. And the very left side is the same as the variables. We can put some modifier here. To put the scope keyword. Here with a plus symbol. This symbol means this method, the scope of the method, access scope is very wide. It's public. Okay. So we got these diagrams. We use UML languages. We draw this picture, and we get what is class. And inside the class, we have variables and a method. How about them? We use this class diagram. Now it's very clear to describe this whole class or whole object. And then once we get this diagram, and next step, we can do coding. We use Java language to write code to implement a class. So here we have a class, it's a keyword. It means now the bicycle is a class. So we have a bracket. Yes. And inside this brackets, it's our class body and three variables here: speed, gears, and RPM, and three methods below: the brake, and change gears, and change cadence. Notice here, it's a name of this class, speed, and its type, and its access scope, private, and its method, this brake method, this name of brake. Now we have parentheses size, and its method body, and it's return nothing, so it's this keyword void, and this plus symbol we use public keyword here. So this is how to do the coding using Java program languages to implement, to write a real code once we get these diagrams of the class. Okay, now we come to the relationships between classes or objects. There's three kinds of relationships between classes. The first is inheritance relationship. The second one is association and dependency. And inheritance, we have two different kinds of inheritance: class inheritance or interface inheritance. And association, the two types: aggregation and composition. We will discuss them one by one. And first, what is the inheritance relationship? The inheritance relationship is quite common. It's ubiquitous. It exists everywhere, you know, in our life. For example, here we have a bicycle. A bicycle is an object. And then we have mountain bike, racing bike, and tandem bike. They are all bicycles, but they have additional features. For example, the mountain bike, because we have special tires. We install special tires on a bicycle, and so we use it as the mountain bike. And a racing bike for race. So it must have a delicate structure, and it's with more lightweight. And tandem bike, it's a bike but with more than one seat. It allowed us, two of us, three of us, to ride the same bicycle. So it's a tandem bike. So they are all bicycles, but they add their own different features. So this is inheritance. It's easy for us to understand. How to describe this relationship? We use this symbol, arrow. Now, the bicycle class we define as superclass, and the mountain bike or racing bike or tandem bike we name as subclasses. And this arrow, we use this arrow to describe this relationship, inheritance, and this arrow must point to the superclass. From the subclass, point to the superclass. From the subclass, point to the superclass. We use this arrows, this symbol in the diagram to describe this inheritance relationship. On the left side is a code. If I have this diagram, how we describe it using Java programming language, here's a code. Now I have a class. This class. The class is for a bicycle. Now we have variables as gear and speed or that kind of things, and effect methods. One method here, change gears and others. And now just mountain bike. The mountain bike is subclass, and bicycle is a superclass. I use keyword extends. Uses words describe this relationship. The mountain bike is derived from the bike from the superclass, and mountain bike is subclass, and bicycle is a superclass. We use extends. Use this keyword to describe this relationship in Java code. And inside the class, inside the subclass, we can define our own variable that is variable not existed in the superclass. For example, the node. And we define different method that is not existed in the superclass. For example, change node. But we can also rewrite this method that has existed in the superclass. For example, to change gears. In the superclass, we have this method named as change gears, but in the subclass, we can also define it as change gears. The same name, but you should write different code here. The code is different. So we give a new implementation of the change gears, this method. We call them overriding. In the future class, we'll discuss it in more detail about how to define this kind of method overriding. This is how the inheritance relationships works for these concepts. The subclass is derived from a superclass. The particular class is a superclass, and the subclass is derived from it. And the superclass is a class from which a particular class is derived. Here, the particular class means the subclass. So the subclass is derived from the superclass. Yeah, we use extend, this keyword, to describe this kind of relationship. Yeah. And next, the subclass. The subclass will inherit what? The state. The state including the variables, instance variables from his superclass. And they can also add extra variables inside the subclass. This is the idea. We can inherit all these variables from the superclass, but we can also be allowed to add our own variables inside my class, inside the subclass. And the same way, the subclass can also override inherited method and provide a specialized implementation for them. That means we can define a new implementation for these methods that have existed in the superclass. But remember, If we don't want to get a new version of this method, we don't need to rewrite them. Okay, we just use them in the subclass. And a very important point, you should know that in Java, the inheritance form a tree. The root of the tree, here's the root of the tree. The root class will limit object. So object is the superclass of all of these objects. Start from here, we derived a lot of classes, and next they as a superclass, and they derived a lot of subclass. This continue. So I have a lot of objects in the tree, and object is a root. So it's a tree. It's very important for us to understand this. In Java, all these objects, if I have these inheritance relationships, they form a tree. It's important idea for that. Here we have an important idea. Another important idea is that we have a specialized class. We limit abstract class. The abstract class can define generic behaviors. That means we only define this function, the frame of the function, but we do not write any real code for it. It's just a framework. And how to implement them? The code must be written in its subclass. And the superclass we name it as abstract class. We use the keyword abstract to mark it, to make it as this abstract class. And this abstract class, inside them, the method, we make it as abstract method. That means this X method inside this class is only framework. Inside, we do not write anything. And we derive the subclass. Inside the subclass, the same class, we have inherit these methods from this abstract class, and then we give this implementation in the subclass. So this is idea about abstract class. In the future class, we will give you more information about this abstract class. I think that maybe the fifth chapter. We're talking a lot of things about abstract class. I'll give you a real example for it so you can understand it well. Okay. Next, we come up to a new relationship between the classes. Its name is aggregation. What is aggregation? The aggregation describes this kind of relationship between class, between the entirety and individuals. The two class, one is entirety, another is individuals. So, what entirety means? What individual means? Here's an example. Now we have a car. A car, a car is composed of a lot of parts. For example, a car will have an engine, and a car have a tire. So a car's object is entirety. And the engines and tires are individuals. So between the car and engine and tire, the relationship is aggregation. Yeah, so one car have one engine. One car have bunch of tires. Yeah, maybe there's no tires. Uh, when we see a car without any tires, I think I have seen one on the street. There's a car over there and without tire. Why? Because all these tires have been stolen. So it's no tires. So a car may have no tires, but it's still a car. Yeah. So we use this symbol to define the aggregation relationships in UML. We use the hollow rhombus and use an arrow. And the entirety to point to the individuals. And we give it number, means one car and one engine. And one car may has a lot of tires, may have no tires, may have one tires, two tires. In general, a car has four tires. Okay, we use a sample to describe this aggregation. This kind of relationship between entirety and individuals. And inside the car, inside the entirety class, we must define two variables here, one for engine, one for tire. This variable name engine, and this variable name tires, and right side the column, it's a type. The type is not a primitive type, it's a reference type. I will give you more explanations about this kind of type, reference type, in next chapter. Okay, and here's a code for aggregation relationship. The left side is UML diagram. The right side is a code. You know, as a code have a car, and inside the car we have two definitions. One for the engine, this variable, one for the tires, and this is type. The engine's type is engine. It's type of engine class. And its tires, the tires is array. It means it may have a lot of tires, okay? And this private means this, it's the same. Here's a modification, is minus symbol means private, as this access scope here. This is aggregation relationship. The next relationship is composition. This relationship is similar as this aggregation. See? It is similar with aggregation. It is between entirely individuals, but it's different from this aggregation relationship because there is a condition that is the entirety should be in charge of the life cycle of the individuals. That means, for example, here we have a man, it's entirety, and it's individuals, a nimble, and a head. It's individuals, right? You know, a man is composed of head and a nimble, four nimbles, and one head. This is composition relationship. And the man must be in charge of the life cycle of the nimbles. So, am I not the man's life? So the nimble must be alive. And if a man's dead, the nimble and the head are all die. That's it, dear. The man in charge of the life cycle of its nimble, of its hands, of its necks, of the arms, and its head. That's the idea. In UML, we use the similar symbols to describe this kind of relationship composition. This rhombus, but the rhombus is filled with corners, and the arrow to point to these individuals. And the same inside the class, inside entity class, we define this reference variable, labels, and heads. And in the right side of the code, and the code we have these definitions for the label. It's array because we have arms and necks, and the head is also a reference variable. And a very important, how to describe this condition. The entirety, the man being in charge of the life cycle of individuals, we should have these statements. Means we will create an object, create its head, create its limbs, because man is in charge of the life cycle of the individuals. So we must have these statements to create the parts of our body. That's the composition relationships.